in this problem, we're starting with a piece of ice that's at a cold temperature, negative 28 degrees Celsius, and we want to turn it into liquid water at 19 degrees Celsius. So the first thing we need to do is we need to heat up the ice. The ice can't melt until it gets to 0 degrees Celsius. And so we would start here by saying, okay, let's look at the specific heat of ice, that we would have to add an amount of energy equal to the mass times the specific heat of ice times the change in temperature. Once we get that ice warmed up to 0 degrees, then we can melt it. And so we want to look at the latent heat of fusion. And so we need to add an amount of energy equal to the mass times the heat of fusion for the ice. And so now we'd have a puddle of water at 0 degrees Celsius that we want to heat up to 19 degrees Celsius. And so that energy would be the mass times the specific heat of, I'll call this H2O for liquid as opposed to just the ice over here, times the change in temperature. And so we could solve each one of these values, add all of those energies together, or I'm going to say that my total energy will be each of those added together. Okay, those three steps: warming up the ice, melting the ice, and then warming up the liquid water after that. All right, so as I start to plug my values in here, I'm going to go ahead and factor out the mass. Okay, so I'm going to have the mass here out in front, the 0.372 kilograms, okay, times all these other things that still remain. The specific heat of the ice itself, I'm not going to put units on all these just so I can make sure they fit on my paper. The 2090 times its change in temperature. We'll have to heat this up by 28 degrees Celsius. Plus, factored out the mass already, the heat of fusion, 33.5 times 10 to the 4. Plus, now for the water, its specific heat, 4186, times its change in temperature. It needs to go from 0 to 19 degrees Celsius. Again, I didn't show all these units, but everything here was measured in joules, was measured in kilograms. And so now I'm going to work on what's inside the bracket. 2090 times 28 plus 33.5 times 10 to the 4th plus 4186 times 19. All right, so that's everything in the bracket times the mass. And so we get 176,000 joules, or 176 kilojoules of energy.